So this number inside here tells us there is a period change. So we're going to do the inverse of what is happening in this parenthesis here, which says 3 times x. So the inverse of multiplying by 3 would be dividing by 3. So I'm going to take the normal period length of 360 and divide it by 3, which tells us the new distance now is 120 degrees. So in our order of steps, we need to deal with anything that's like sideways, horizontally, before we deal with any of the vertical stuff. So we're going to deal with this period change before the vertical shift. So, I don't know, that was a weird noise. Anyway, so what we're going to do is take our normal intervals here. My computer is freaking out, I guess. Oh well. We're going to take our normal intervals here and divide them by 3, just like we did with the typical period length. So 0 divided by 3 is still 0. 90 divided by 3 would be 30 degrees now. 180 divided by 3 is 60. 270 divided by 3 is 90. 360 divided by 3, we just did here, right? It should be 120. So this entire distance, again, that's called the period. So that should go from 0 to 120, since we didn't move anything from the start at all. That would be a phase shift. So we dealt with the period change now, so we can check that off. The next thing we're going to do is deal with the other change, which is our vertical shift. And this is a cosine graph, so that's just a good thing to kind of check before you start graphing. What kind of graph is it? And make sure we do the right one, because I'm very prone to doing the wrong one every once in a while and graphing the wrong function. So it happens to all of us. So there's our regular cosine graph. We dealt with the period already by changing the intervals here, so we're just going to do the up 2. So I'm going to take all of my values and go up 2 units. So I'm just going to extend my graph a little bit in that direction. So from 1 up 2, now we're at 3. Up 2, we're at 2. Up 2, we're at 1 now. And then 2, and then 3. It should be the same shaped graph as before. It's just kind of shrunk down. It's happening in a shorter period. So if you notice before, between each of the intervals in the normal regular just cosine graph or sine graph, it's normally a distance of 90 degrees in between. So what's happening now is there's only 30-degree difference in between. So it's happening in a much shorter amount of time. So that's really what's happening with this period. It's like shrunk together and it's happening faster, even though the graph looks the same as a regular cosine graph. Okay, so that was just period and vertical shift change. Now we're going to put 3 things together. This is also from the homework 710 day 2. This is number 13 in that homework assignment. All right, so the next one after that. So again, I like to just kind of identify what changes we have happening first before we start graphing anything. So this number in the front is going to tell us there's an amplitude of 2, so it's going to be stretched taller. Inside here, it's not being multiplied, but it's being added or subtracted. That is a phase shift, left and right. And we're going to take the opposite of the plus 90. So that's going to be moved. You could either say left 90, or you could say minus 90, whichever one makes more sense to you. And then finally on the end we have minus 2. So that's my vertical shift, down 2, or you could say minus 2. All right? So now we know we have these 3 things to deal with. So in our list of steps, we're going to address anything that moves horizontally first, so with our phase shift. So that means we're going to take our normal intervals here, which we normally start at 0, we're going to shift them all over 90 degrees to the left, or basically subtract 90 degrees from each of them. Right? So instead of starting at 0, we're going to start 90 degrees to the left, which is actually negative 90. Right? Our next interval is typically 90 degrees. If I take away 90 from that, well, now I'm at 0. 180 minus 90 is 90. 270 minus 90 is 180. And then 270 is our end. All right. Now our period length has not changed. The distance between the start and the end from negative 90 to get to 270 is still 360 degrees. The period is still 360. That has not changed at all in this particular one. Okay. So we've dealt with the phase shift. Check that off. Next, -1, -2, -3. Next, we're going to deal with the amplitude, right? In terms of of these two pieces, we would multiply first, right? This is kind of like in the parentheses. So if thinking about PEMDAS, we do things in the parentheses first, and then we deal with this multiplication and then the minus or addition on the end. So it's just like following PEMDAS in our order of which we should do first. So I'm going to graph the regular sine curve at the same spots in terms of the y coordinates, right? Our x coordinates have all been shifted to the left 90 from where they started. So deal with the amplitude and multiply each of those values by 2. So this stays. This one, 1 times 2 is 2. That stays. Negative 1 times 2 is negative 2, and this stays. All right. I like to just do one thing at a time because sometimes we get overwhelmed and we miss one point and it's just not actually accurate anymore. So just focusing on one change at a time should hopefully help you be more correct in your graphs. So the last thing is our vertical shift. We're going to remove everything down 2 units. So down 2 is going to be negative 2. From 2 down 2, now we're at 0. This down 2 is at negative 2. This one was at negative 2. Down 2 more brings us to negative 4. So I need to extend that down a little bit further. And here we're at negative 2. So here's my final version. This is actually this equation in the pink, right? Now we can graph this kind of quickly to check that you're graphing it right. Whatever kind of calculator you have. I'm just going to type this equation in here. So 2 sine of x plus 90 and then minus 2. And when I graph it, I have it on some random window setting from before. So we need to adjust our window. Whichever calculator you have, we can adjust it to start from here for the x and end here with the x. So I'm going to go to my window, however you get to your window settings. If you have a TI Inspire, it's usually menu and then window settings, I think is number 4, and then you'd probably choose the first one. So we're going to go from negative 90 for the x to 270 for the maximum on the x. And the y minimum, the lowest that this graph touches is negative 4. Highest it goes is 0. Now you could go a little bit higher or lower or farther from that. But if you like restrict it to this, if you were to draw like a line or a rectangle outside your graph and you restrict it to that, you should see just one exact cycle of either sine or cosine, whichever function it is. So that kind of helps me check that my labeling is right, my points are correct. So that's a way to check it besides just looking at the answers if your teacher, sends them to them. So we're going to look at one more where there's just 3 things changed, and then we'll look at all 4 of them here in a final video because I don't want this to be too long. So this question is from homework 7-11, and it's question number 2. So we're going to have a couple things happening here. We're going to have an amplitude change, a phase shift, and a vertical shift. So we're just identifying those first. All right, a phase shift is when we have something inside the parentheses that's being added or subtracted, and it's going to be the opposite. So this plus 30 really means I'm moving left to 30 degrees, or you could say minus 30. We're going to take away 30 from all of them. Now, this number in the front, 2 minus 5, right? The 5 is being multiplied with the cosine. So we're not going to just do 2 minus 5 and change that entire number in the front. Still thinking about the order of operations, we would need to do 5 times this cosine stuff first before we do anything with the 2. Now this 2 in the front is actually the same as putting it as a positive 2 in the back. And now that might be a little bit more obvious that, oh, that's my vertical shift. So our vertical shift doesn't always have to be in the back, it might be in the front sometimes. But I'd maybe just move it to the back to make some consistency, and then it stands out a little bit more. So here's our plus 2 for vertical shift. So up 2, or you can say plus 2. And then our amplitude is really 5, but we know it's going to be flipped. So just make a little star to maybe note that to yourself. Right? I'm going to maybe make my axis be here because I don't want to run into that number I made over there. All right, so dealing with the order of things. So we're going to deal with anything that's shifted horizontally or changed horizontally first. So that's going to be our phase shift here. So we're going to take away 30 degrees from every of the normal intervals because it's shifted to the left 30. So instead of starting at 0, we're going to say this is negative 30. And you could always keep that y-axis in there at 0 and just like move the 30 back a little bit. It's just whatever makes more sense to you. But I like to do where I start is on that y-axis there. So it's at negative 30. Next one, minus 30 would be 60. 180 minus 30 is 150. 270 minus 30 is 240. 360 minus 30 is 330. Okay. Now the period has not changed. There's no number being multiplied in front with the x. So my distance from where I start and end is still 360 degrees. So we did the phase shift part. Next I'm going to draw the regular, whichever, let's see, we got a cosine graph here. So I'm going to draw that one first. Just plot my points. And again, I'm just going to use a dashed line to say, hey, that's not my final answer yet. So the next step between these two, we're going to deal with the amplitude. Now we're still multiplying by negative 5 because it needs to be reflected. So I'm going to have to make my graph have a lot more points on it. Let's go with that. And we can always add more. Some of you like to just adjust the axes here, which is fine, but I would just be careful with that and make sure you label every little spot that there ends up being a point at. If you just label like the top and the bottom, then it's kind of hard to tell exactly where everything is in between. So we're going to take all of these y coordinates and multiply them by negative 5. All right, so 1 times negative 5 flips it down here. This stays the same. This flips up to positive 5, stays the same, down to negative 5. So again, dashed line to say, hey, that's not done yet. That's what I like to do anyway. And then the final thing, so we did that, last thing is move everything up 2 units. So from negative 5, now we're at negative 3. This becomes at 2. This moves up to 7, 2, and negative 3. Right? These graphs should be symmetrical. Whether it's sine or cosine, there should be some symmetry, so you should get several of the same points. Okay? So up to there is just we've had 2 or 3 different transformations happening. So we'll do one more video where there's all 4 things happening.